S-Chan presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
We know that as the system, when the system is moving, the waves are associated with the bodies, and also waves are associated with the moving particles. Now there is a group of waves are present with the particle. How that the group waves are moving as a collection, there is some velocity which is related to the wave, but when there is a single wave, there is also velocity related to that wave. So that can be calculated in terms of phase velocity, group velocity. Phase velocity, that is a velocity which is associated with a single wave, and when these waves move in a bunch or the group velocity is associated with them. So now that we will understand in the upcoming article.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
Welcome to S-Chan Academy, myself Dr. Narendra Kaur. Now let us start with the topic. So firstly we will understand what is a wave. So wave is basically, it is defined as a disturbance in the medium. When the equilibrium disturbance in the medium from an equilibrium position, and that propagates from one region to the another region. Now the wave, that can be the water waves, they can be standing waves. So there are all kind of waves are present. We know that, or when the one particle is moving from one place to another place, or the waves are transferring also from one particle to the another particle. So due to motion of the particles, we know that there are a group of or the bunch of the waves which are associated with the bodies. Now we want to calculate what kind of waves are associated with the bodies and how we can represent these waves. So these waves that can be represented mathematically in terms of some velocity factor. So this velocity factor, that can be the phase velocity or it can be the group velocity factor. Now that means, now we can represent wave. We know that for any wave, if this is the value of the wave, amplitude of the wave, so that can be represented as E a raised to power iota omega t. So that is how we can represent a wave. So wave, it includes now if y is a displacement of the wave, so it includes two parts. One is amplitude and second one is a phase value. So here A, it represents the amplitude, and what is omega t? It represents the phase of the wave. That means a continuously wave that is associated with the moving bodies or the moving particles over here. Now when the bodies or the moving particles, they have the smaller mass, so that can be easily distinguishable or that can be easily seen, while for the heavy bodies, these waves that cannot be seen for the heavy bodies. Now we know that the wave that is represented by this A e raised to power iota omega t. So what is A? A is amplitude and this is the phase of the wave over here. Now the wave that can be represented like this. So this is a wave which is propagating along the x-axis, and with the time t, its amplitude that goes on changing, because when there is a simple harmonic motion, so that will remain constant, while for the damped harmonic oscillator, it will goes on decreasing over here. So now if there are the large number of waves, we know that when there are the large number of particles, now when you take 1 mole of atoms which are present in the crystal, so with the each atom, and when some heat is supplied to these atoms, that means when heat is applied, all the atoms, they will start vibrating about their mean position. That means for 1 mole of atom, the number of atoms, that will be 6.023 into 10 raised to power 23 atoms. That means all these atoms, they will vibrate or they will move about their mean position, and due to motion of the each and every atom, there is a large number of waves are associated with associated with all the atoms. That means all the atoms, they are having the waves. So means in our system we are having this, if these are the kind of atoms, number of atoms, and these will be the number of waves which are associated with the each and every atom. So that means for the whole system, the large number of waves are associated with the given crystal or 1 mole of atoms. Now we want to calculate the velocity of each atom. So that term is defined over here, that is known as a phase velocity. Phase basically it represents or it shows for the single atom how the single atom moves, or a single particle or a single body moves, and the waves which are associated with the single atom, or you can say that that is for the single wave. Now when the single atom or the single particle, it firstly let us consider it vibrate along x-axis, then it vibrate along y, and then vibrate along z-axis. Now we want to calculate the single wave which is associated with the particle. So that single wave is represented in terms of phase of the atom, because it directly represents phase of the atom. So that velocity associated with these atoms, they are known as a phase velocity. So now the waves which is defined as, it is defined as a disturbance in the medium from its equilibrium position. That means a particle that is stable at the equilibrium position, not disturbance from its mean position or the equilibrium condition, that is known as wave, and which is propagating from one region to the other region. Because when the once in the given system when one thing is vibrating, so that will be transferred to the another region also. So when such type of wave propagate in the medium, a progressive change in the phase that will take place from one particle to the next particle, because in the given system when there is a bunch of atoms are present in the given crystal, so they one particle or one atom or they are associated or they are correlated with the another particles also, and due to presence of these bunch of the particles, these wave that will propagated in the medium from one to the another particle. Now such group of waves or the bunch of waves, so there will be presence of group of waves. So group of waves, or which is known as a bunch of waves, they are also present in the given system, because in the given system there are the large number of particles that are associated. That means if the with one particle one wave is associated, let us consider with one particle when one wave is associated, then with 1 mole of atoms, so there will be 6.023 to 10 raised by 23 atoms or 23 molecules are present. So automatically that number of waves are present. So that bunch of waves or the group of waves, that is known as bunch of waves or the group of waves. So now we know that the propagation of wave, so propagation means the movement of wave. Now the propagation of wave in the medium, that will occur with 2 different kind of velocity. One is known as a phase velocity, second is known as group velocity. Now we know that when the wave is moving in the system, so when any body moves, a velocity is associated with it. So either it has a wave, particle or any body. So that means the velocity is associated with the waves. Now that velocity is defined in terms of phase velocity or the group velocity. Now we want to describe these 2 terms. So firstly we will describe what is a phase velocity. So phase velocity is the velocity of the single wave. That means we will consider, as there are the 6 point in 1 mole, if there are 6.023 into 10 raised to the power 23 atoms or the molecules, with each and every single atom the wave is associated. The velocity of that wave which is associated with these individual atoms, that is known as a phase velocity. That means the velocity of the with which the wave is continuously propagating in the system, that is known as phase velocity or wave velocity. That means if there are the large number of atoms, each and every atom, that means the single atom, each and every atom, they are having the wave associated with them, and the wave associated with a single particle or the single atoms, that is known as phase velocity. Now what is the group velocity? Now we will define the term over here. So group velocity, this is also defined as the velocity of a bunch, means when all the waves they will superimpose on each other, so they will represent a bunch over here. The group velocity, that is a combined velocity of all the phase velocities. So there are the large number of atoms are present. Now we will summarize all the velocities from all the atoms. So for the single atoms, the velocity associated with them, that is called the phase velocity, and when we summarize all these velocity, they will turn to the group velocity. So the phase velocity, it is defined as a velocity with which plane of constant the phase of a wave propagates. So that is a velocity of a single wave which propagates through the medium of a certain frequency, that is called phase velocity or wave velocity. Now we know that the velocity of light, that is equal to c, which is equals to 3 into 10 raised to the power 8 meter per second. We know that all the waves are light waves, they are moving with this velocity. So there is no requirement of medium, but in case of waves or the phase velocity, when there is a requirement of medium, this phase velocity, now we will derive its relation, it comes very much greater than c, but that is not possible. So that means for an atom, when it is moving in the system, that means it's not possible for a single atom to move in the system. So the bunch of atoms, they will combiningly move in the given system, and the velocity associated with these atoms, that is known as the group velocity. So the phase velocity, that is known as the velocity of a single atom. That means now the velocity of a single atom, that can be calculated. So now this is a single wave which is represented or present in the given system. Now the velocity of this single atom, that is given over here, which is equals to Vp. Now in this case, that can be written as dy by dt. So that is the rate of change of displacement with respect to time. It will show us the phase velocity over here. So now we have studied in this part, we have studied over here. Now we will go for a short break. Now we studied what is a group of waves, what is a bunch of waves and the wave associated with the particle, and what is a phase velocity. Now after the break, we will calculate its mathematical part or the mathematical derivation of the phase velocity.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Now welcome back to S. Chand Academy. So before the break, we have studied what is a wave and the phase velocity associated with a single wave. Now mathematically we will derive the expression for it. So the phase velocity, now we know that in order to describe the phase velocity, we will consider over here the single wave. The single wave that is associated with the particle, only the single wave is represented over here, and the phase that is associated with the single phase. So the velocity associated with the single wave, that is equals to phase velocity. Now we know that a plane wave which is traveling in the positive x direction, that can be represented by, which is equals to a sine omega t, or you can write this as now what is over here? A is amplitude of the wave, and what is omega t minus kt by v, that will represent over here the phase of the wave. We know that the wave, that can be represented by two components. One is a phase of the wave and second one is the amplitude of the wave. So combining these two factors, we will calculate over here the phase. So the wave that can be represented over here, that is a sine omega t minus kx by v. So this is the representation of wave. What is omega here? Omega is a angular frequency that can be calculated over here. So angular frequency, that is equals to x omega by v. So now what is here? That can be written as, so a sine, so we can write this as y equals to a sine omega t minus kx. So this is a representation of a wave. So this is a representation of a wave. What is amplitude, and second one is a phase. Now we know that for a plane wave or the single wave, omega t minus kx, that will represent phase of the wave, And now for the wave of plane of constant phase wavefront. Constant wavefront means the wave is continuously moving with a single phase. Its phase is not changing, because as the phase wave or the phase velocity, that is a velocity which is associated with a single wave, and that is moving with the constant phase always. So when this phase is constant always, then consider this is equals to phi, which is constant. Now differentiate it with respect to time t. Now we know that now if this is equals to some constant, so that means omega t minus kx. Consider this is equals to constant, which is equals to phi. Now differentiate this with respect to t, we will get now the differentiation of t with respect to time, that is equals to 1. So that is equals to k dx by dt. Now that will be equals to 0 over here. So this is the derivative over here. So this is the first order derivative. Now we will get over here. So again omega, that is equals to k dx by dt. So the dx by dt, that is equals to omega by k. Now what is here? This is a phase velocity, because we are considering only single wave over here. So this is a Vp, that is a phase velocity, which is equals to omega by k. So this is a velocity which is associated with single wave. Now phase velocity is omega d by dk. What is Vp here? That is a phase velocity of a wave. So this is a single wave associated with the body over here. Now next we want to calculate different expression for the phase velocity. How you can calculate? The single expressions for the wave velocity that can be calculated over here. Now we know that the phase velocity is, that is a omega by k. Now in order to calculate the phase velocity, we want to show that the phase velocity of matter waves always exceed the velocity of light. Now we want to prove this. How you can prove this? We know that the phase velocity is omega by k. Now omega, we know that that is equals to 2 pi f or 2 pi nu. We know that the omega can be written as, and k, that is equals to 2 pi by lambda. So what is k here? That is a spring constant over here, but in this case this is known as a propagation constant. So for wave, that is known as the propagation constant. On substituting these value over here, we will get phase velocity, that is equals to E by P. So the expression for the phase velocity is 1. So the first expression is phase velocity, that is equals to omega by k. Second expression is a phase velocity, that is equals to E by P over here. What is E here? That is the energy of the body or the energy of the wave. What is P? That is a momentum associated with it. Now when we are taking the waves which are associated with a particle, so in that case for the particle, energy E, that can be written as mc square, that is according to the Einstein principle, and the momentum associated with the bodies which are moving with velocity v, that can be written as m into v. So the phase velocity, that is comes to be equals to c square by v. So that means the phase velocity is very much greater than c square. So that means now the different expressions for the phase velocity are, first one is a, so the phase velocity, that can be written as Vp. First expression is a omega by k. Second is a E by P. And third is a c square by v. So these are the three different expressions by which we can calculate phase velocity of a wave that is moving. Now in the second expression, we know that phase velocity, that can be written as nu into lambda. Now substitute the value of nu over here and the lambda, we will get Vp equals to c square by v. What is v here? That is the velocity of the matter particle. Now main concern is over here, the phase velocity, that is equals to c square by v. Is it possible or not? So that is not possible. So that means our phase velocity is here. C square by v. We know that the velocity of a body, what is v over here? That means Vp that is equals to c by v. What is v? That is the velocity of a particle. What is phase? That is a phase velocity is the velocity of the wave which is associated with the moving particle. Now v is the velocity of particle. V is always less than c. It can never be equals to c. That means all the bodies, all the particles, they are moving with the velocity which is lesser than the velocity of light. So that means if v is very much less than c, no body or no particle that can move even with the velocity of light also. That means this v, that can never be equals to c. It is always less than or equals to c, because there is no body or no particle which can move with the velocity of light. Their velocity is always less than the velocity of light. So means all the particles, they will move with the smaller velocity. Now if v is very much less than c, that means a phase velocity. Now if this v that is very much less than c, then that means a phase velocity is very much greater than c square, or you can say that the phase velocity is very much greater than c. What is c here? That is a velocity of light. So is it possible? That can never be possible. So that means the particle, it is moving with a smaller velocity, and the wave associated with the particle, it moves with the velocity which is higher than the velocity of light. That is not possible. That can never happen. So according to this expression, here we will realize here. So that means Vp, as it is very much greater than c, that means if this is the, now if here is a particle which is in the moving direction, it moves along the positive x-axis. We know that the wave is associated with the particle. Now here the particle is moving with the velocity v, and the wave associated with the particle, that is moving with the velocity, phase velocity, which is c square by v, and very much greater than c. So that means the particle will left behind, and the wave associated with the particle, it will move faster than the particle. So is it possible? That can never be possible, because when the waves are associated with the particle, they have to be moved with the particle. That means when the velocity of the particle is v, if v is, that is a velocity of particle. So that is a velocity of particle. That means a particle is moving with velocity v, then the phase velocity. What is phase velocity? That is a wave which is associated with the particle. It has to be along, or it has to be according to the velocity of particle. So it can never be more than c. It can never be more than velocity of light. So that is not possible. So now all these things that can be resolved in terms of, that means it can never be equals to c or get greater than equals to c. That means the phase velocity, that can never be possible. Now how you can resolve this? So these things that can be resolved by considering, instead of single wave, there are a large number of waves which are associated with the moving particle. So the single wave, or you can say that the phase velocity concept, that is removed over here. So according to which, when the particle is moving, or when a single particle is moving, instead of single wave, large number of waves that are associated with the particles, and the bunch of that waves, they will corresponding to the velocity, and that is always equivalent to the velocity of the particle. So the phase velocity, that can never be greater than c. So this is the assumption over here. So that means this assumption is, that is not true over here, according to which the phase velocity, that is the velocity which is associated with a single particle. So that means when the waves, they are transferring from one media or from one region to the another region. So on transferring wave from one region to the another region, the group of waves are transferred instead of single wave. So that means there are the large numbers of waves are associated with the particle. So that means we can represent this like this over here. So that means now instead of single wave, So that means if there is this one wave, so the large number of waves, they are propagating with the particle. So that means instead of single wave, there are, when the particle transfer information or when the particle transfer energy or information in the given system from one region to the another region. So instead of single wave, a bunch of waves are transferred, so that the energy or the velocity associated with the particle, that is given in terms of group velocity instead of phase velocity. So the phase velocity now expression, that is equals to c square by v. So these are the myths. So according to which the Vp, that can never be more than v. So that is equivalent to v. So depending upon that, phase velocity, that can be taken equals to omega by k, or that can be taken equals to E by P over here. So E is that is the energy associated with the particle, and MP is the momentum associated with the particle. So this is a concept of phase velocity. So now this is according to which where the velocity of the matter waves. That means for the matter waves that is not possible. Now when we are calculating the phase velocity for the light, we know that for the light this V, that is equals to C. That means for light waves, this V is equals to C. So automatically phase velocity, that will become C square by C, that is equals to C. We know that the light waves always travel with the velocity of light. So that is a true in case of light waves. But for the metal waves or for the materialist particles, when they are moving in the system, the velocity, the phase velocity associated with them, that cannot be represented by the single wave. So that can be represented in terms of bunch of the waves. So this is the concept of waves and how the waves are propagating in the system. And for the material bodies, when the waves are associated with a particle, they are considered as a bunch of the wave instead of single phase, because the phase velocity comes greater than velocity of light, that is not possible. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.